Okay, the most common query by geography is intersect. It's the one we use most often. You can use any point line or polygon as a source and also for a target. Here I am trying to subset those live stream gauges. You can see that some of them are outside the county, and I'm going to go ahead and do an intersect so that I get only the stream gauges that are inside the county. So you can see I'm going to pick the intersect. And remember that for every query, there's the opposite query. So I could have found the ones that were outside the county and not inside the county. And I'm picking up the Knox County. It's actually a bunch of counties, but I filtered for Knox County. So that's what the analysis will be done. And I'm going to go ahead and name it something unique, because remember, they kind of all end up in the same bin at UT. And run the analysis and make sure that I, chop off those ones that aren't in the county, which I did. After the analysis runs, you can see that just those live stream gauges in the county are there. Okay, so the next thing I'm going to do is I've focused in on Goose Creek watershed and trying to look at the parks that are in the watershed and giving you some examples of completely contain and intersect. So I'm going to do the intersect first. And just to show you how the difference is, remember, once again, intersect, you can use any point line or polygon for either the source or the target, whereas completely contain, the target layer has to be a polygon. So in this case, I'm trying to find the parks that intersect Goose Creek watershed, and you can see the outline of the watershed like right through there. It's that blue line that kind of squiggles all around. And so when I run this analysis, you'll see all the parks that are either completely within or even touching the border. So we have 6 parks that are considered intersecting the Goose Creek watershed. And now I'm going to switch it and do an analysis where they now have to be completely within. So they can't just be touching or being crossed by the boundary. They have to be completely within that particular watershed. And actually, this is, I should have gone back to the original watershed up there. So I did correct that. So we're actually within the Goose Creek watershed, not the park intersect. So now when I run that analysis, you see there's only 3 of the parks are selected instead of 6, because these are only the only 3 that are completely within the watershed. And I'm just giving them some different colors here so you can tell the difference between them, between the ones that were selected with intersect and the ones that were selected with completely within. So we see these are the 3 that in green that are completely within, and then those additional 3 were the ones that were selected in intersect. You can see why. If you zoom in there, you see the watershed boundary is actually crossing that park up there, so it's considered intersecting with the watershed. So just to kind of show you the difference between those 2. So it just depends on whether you think the feature, if it's important that just part of it be within your selecting polygon, or if you want the whole feature to be in. Now for points, it's usually not an issue, but it becomes more of an issue with lines and polygons of whether they're completely within the polygon that you're using as the target layer, or are they just touching some part of the polygon. So the next thing I'm going to do is to find out which watersheds completely contain a park. I'm turning off some layers just so I can show you or get you a better view of just the layers that we're interested in. So I'm going to do, on the watersheds, I'm going to do a feature analysis of finding locations. This is a query by geography. And I'm going to find the Knox watersheds that completely contain, so it means the whole of the park has to be in the watershed. Otherwise, you would just use the intersect if you didn't care whether it was just part of the park or not. Now I want to know which watersheds have an entire park within their confines. And I'm just naming the layers something so I can go back later and kind of know which layer came from which geography query. And now you can see when I run that, these are the only watersheds here. I think there's 18 of them that completely contain a park. And I think we had originally 41 watersheds. And these watersheds have actually been clipped by the boundary of Tennessee, so they're not always a complete watershed. Some of the watershed might actually run outside the Knox County boundary, but that's a tool you'll learn how to use in the next few weeks, of how to clip layers. So now the next thing I'm going to do is look within a distance. I'm trying to find existing locations of schools that are within a certain distance of a park. So, for instance, if I was going to have some sort of an environmental outdoor lab or something, I might know which schools could perhaps participate if I have it at a particular park. So I'm saying pick the schools that are within 1 mile of a public park. And that might give me some, ability to focus on the schools where I could have some sort of an environmental program that I could have at the local park. Maybe showing them some erosion studies or talking about trees, or doing something fun with GPS, having a geocaching activity or something like that in the park. But it would probably only work with schools that are close to a park. That way they wouldn't have to worry maybe so much about transportation. So now we can see that this subset of schools, the one in the blue little buildings there, are the ones that are within 1 mile of a park. So these could be the ones we could focus on for some of our environmental outreach programs. And then the last thing I'm going to do is I'm going to try to find the stream segments that are closest to a school. So if I was going to go into the school with some sort of a water quality study, and we were going to kind of adopt a local section of the stream, this would give you some idea of what stream segment you might consider adopting or having an outdoor lab at, or something like that would be the closest to the school. And of course, some of them may not be that close to a school, and it may not be, reasonable to do that. But this would give you at least some insight into some of the stream segments that are really close to the schools. And you might have gotten at this too by, looking at within a distance of two could have worked. But this one just tells you which one is closest. And I turned off that current map extent because you can see I actually don't have all of Knox County in the map extent, because I wanted you to be able to see the symbology okay. So now when I change it, you can see for all the schools, you can see the little stream segment that is the closest to each school that you might consider, encouraging the school to, adopt it or do something. It's kind of amazing that, most of the schools are very close to a stream segment. In that case, it was close to Burnett Creek.